Hello, everyone, and welcome. This is the second session of the Roundtable, Scholar Darwinism, Is There No Alternative? By Mstyslav Kazakov, my dear colleague. Mstyslav, please take it away.
Thank you, Rafael. Hello, everyone. So I will share my screen. I suppose it's visible now, but at the moment, need to um need to uh,
Yeah, when you do the full screen, it's yeah, now it's good. Yeah, it's perfect.
okay, great. So today, it's just a brief plan for today. We'll start from technical solutions, considering the alternatives to scalar Darwinism, or to issues that were outlined during the previous session. Then we'll do some ethical implications and some final thoughts, final remarks. So when we speak about technical solutions, here I mean different types of qualitative alternatives, the feasibility of which we will now review one by one. So the first potential alternative to some of the aspects of contemporary ontology of AI, precisely the scale as a threshold or bottleneck to those who are not in power, who don't have infrastructure, and so on and so forth. So the idea actually comes from the to 2013 or so, when Nick Bostrom first published Superintelligence and got a funding for his Future of Humanity Institute, which is now defunct. So one of his colleagues, Eric Drexler, proposed the idea of narrow superintelligences, so to speak. He thought that monoagentic AI, if we will seek it, would without any possibility of solving the problem of alignment and control, would become the disaster. Although not as in a way as contemporary doomers posited, but something like that. So unpredictability on agenda, and so on. So Drexler basically offered to replace the generality, which is always taken as a holy grail of AI research, by modularity and synergy, so that the swarms, or so to speak, or batches of narrow AIs would yield the superhuman performance on narrow tasks, and would demonstrate emergent capabilities which none of them would have alone. So he called these comprehensive AI services. Now, to a certain extent, we might say that his idea is realizing, partly at least, nowadays, because we have plenty of implementations of the so-called small language models, and we also have their like manifesto and position paper titled, as you can see, like small language models are the future of agentic AI, where they argue that the approach of having the model with small parameters is not just sufficient, but can be even better, because because when we speak of agentic AI, this is not the agency which perhaps you associate the term with. this is not about just autonomy and so on, or true self or imitation of self. Agentic tasks are actually more like subtasks, or small repetitive and tiresome tasks, for which to use big or large language model with like 120 billion parameters is sort of using a sledgehammer on sub thumb stacks. So I will demonstrate the video of what is actually agentic task, and then we will discuss it. I used it for my working proprietary database or website in my KPI, Kyiv Polytechnic University. I instructed the model to click each of the, as you can see, link of the document and check whether all the students have marked, have been graded. Here I slowed it down because the model detected that there is an empty document. It like raised alert and so on, and it have been clicking until the end, until the 31st document, and it then gave me the report that all is good except for the number of empty document, and like it said, so this document is a red alert as I have instructed it. So this actually is you can see red alarm. This is an agentic task, typical of them. So this was performed efficiently because this is Perplexity's browser, so on and so forth. And as an addition to browser, okay, to my function, but to deploy locally, for instance, a huge GPT OSS 120B billion parameters would be like very redundant, and local run of such a big model is problematic. But it is the idea is that we get the models like that used for these tasks of localized size. Then what followed was creation of small parametered reasoning models, which were good at chats, for example, as chatbots, or some other functions for which we usually use bigger models. But the limits are the types of tasks, because the better performance model shows the smaller and more granular tasks are in terms of when we speak of agentic AIs. Another paradigm is neurosymbolic AI, which is perhaps more interesting, because here we also would review a little bit the historical development of AI in terms of ethical aspects, or as you can see, the Portman term, which I termed upper hand principle of history. This means that so because computer sciences yield the products which are subject to commercialization by capitalists, weaponization by nation state, or intelligence or army, they are not only subject of pure research and academia works exists in itself, but they are the subject of interest of these different agencies or actors. And because of that, the history of computer sciences, and precisely artificial intelligence, is perhaps the most or the only living model of the science as it was put by epistemological anarchism of Paul Feyerabend. The principle anything goes, not everything, but anything. Okay, which means here to gain the upper hand over the competitors. So, which means like to get the funding, to get the infrastructure, to be approved by the university or institute board. For example, when you propose the research direction, and this will include not only just funding, but education, preparation of PhD students, so future scientists, and so on. So this is the field, or upper hand is a situation in general where not only truthfulness or like better data or any other intra-scientific criteria can be countered and even like overwhelmed by externalities, which may include just being a better reader or better speaker, but not necessarily to propose the more verifiable or more robust theory manners. One's look, because here we appeal not necessarily to the fellow specialists, but to those who just can hold the keys from the research, so to speak. And this is all about that because of these externalities. So some less productive, less fruitful research program may take place. This is not the same as, for example, transition from pseudoscience alchemy because of its failures. Or it's also called like proto-science, and alchemy is like contemporary. If alchemy is today, it's pseudoscience. Then back in the days, it was like proto-science, which was proven to be false. So we have chemistry. In computer sciences, there haven't been such a progression from less to more intelligent machines. When we speak about two main paradigms, the precluding one is symbolic AI, or it's also called, like ironically, good old-fashioned AI, GoFi. And here we may speak that the approach itself has perished because the funding has been drained, has been seized fully, because the diminishing returns eventually overwhelmed all these spendings. But when the symbolic AI was the upper hand, had the upper hand, the paradigm which was neglected and looked from above, it was looked from above, was exactly contemporary machine learning paradigm. So in 80s, people looked at multi-layered perceptrons, which is abbreviation, as relics or like fancies and so on and so forth. Neurosymbolic AI, on the contrary, represents not the same look, which is a response of machine learning endorsers of 80s, now on the last remnants of purely symbolic approach. So this is a combination of neural network with machine learning. When we have rule-based systems and knowledge representations, discrete logic of symbolic AI, and use it, try to use it with flexibility and pattern matching competencies of neural networks. For a long time, it has been just a promise, not for a long time, but about 2 decades. So the main promise was to deliver common sense to the neural networks, because common sense is still believed, common sense logic, common sense reasoning are still believed widely to be the key to generality, or to improvement of generality, or just the road to more general AI system, or even general AI. So actually, now it's not just a promise. We have the use of neurosymbolic systems in warehouse logistics, as you can see. And what is more impressive when we speak about particularly Amazon, despite it's a big tech, was the implementation of provers, formal provers, which are themselves not intelligent programs, like things that proves either theorems or logical arguments in different logical systems. So they implemented these provers directly into training loop of their flagship model Nova, which led to almost 99% accuracy, as you can see. So almost all the tasks were solved. This was tested not against unknown metrics of benchmarks with cryptic parameters of efficiency that we've seen on the previous lecture, but more like step-by-step tasks from mathematics. So yeah, also 99%, but now in terms of the following thing. So MIT, non-commercial and research organization, as you can understand, because like MIT is one of the leading centers of research in academia of the field. So they have proved that if we use a symbolic component learning approach for computer vision, we can reduce the data by 99%, which means we do not need image nets like the image data sets with millions of images for machine to learn the concepts and visual representations, which means that we do not hire data annotators from Amazon Mechanical Turk, do not exploit them. We do not use one's personal photos for the data set. We do not enforce bias in computer vision, like when we write when data annotators use categories like ableist, lookist, sexist, and other in subcategories which were in ImageNet, we can more clearly introduce and more clearly categorize if we reduce, as I said, from, for instance, 14 millions to, for example, 14,000 of images. This is a human feasible task that doesn't need such a big volume of work, and people that are doing it. So okay. Also, there was recently, about a couple of years ago, the audacious and well-known case when the language model created non-existent cases for a lawyer who referred to them in the court as if they were real cases for his own case. Afterwards, he was held. He has been held responsible for like fooling the court or something like that. So here, the trial runs were made with improvements, because symbolic AI is first of all a rule-based system. So it's based, it like rests on implications. In case of phi, do psi, and so on. The problem with rigid rule-based systems, not hybrid, was in that the rules often came into conflict. They required meta rules required meta rules to conciliate the conflicting lower like subordinates. But with neural networks adaptability and flexibility, the conflicts were like more bearable, because the decisions were made more flexibly. So some implementations of these rule-based elements, so to speak, led to more successful use cases, at least on test runs, more robust performance for court, I mean, like for law activity and for HRs. Reducing errors and hallucinations. Well, when I speak about K-weights, what is wrong with neurosymbolic AI, for example? So this is still not a qualitative shift, but it is rather like regurgitation of the old things. And it is far from certain that this actually would engender the common sense reasoning, because, well, it seems so from the viewpoint of common sense, but human common sense. It seems likely that if we plus this and this, it must yield what we would like to have. But if we will, recall that this is just an analogy, this is not literal learning. This is not these are not the processes that human mind undergoes. Sorry. And so on and so forth. So these are analogies, and sometimes, well, harmful analogies. But they may work as negative heuristics, in a sense that if X is implemented and X doesn't lead, to general intelligence, then perhaps we should cross out or rule out X from the list of what was previously considered, for instance, as necessary feature or trait without which the intelligence as such is impossible. Also, the approach relies heavily on big tech level resources, transformer architectures. So it can be tested only by big tech or by highly research facilities with high reputation or with a lot of funds, because Chinese Academy of Science is actually not considered to be like particularly AI research, like like one of the top AI research facilities. But at the same time, they have co-authored many American or European authors and researchers because they have funds to invite people for conference and so on. So what kind of alternative neurosymbolic AI offers is like a new paradigm and episteme, but only potentially, especially if we will also add to the best practices of the good old-fashioned AI, the attitudes toward cognitive sciences, neuroscience of those years from 50s, to the end of 20th century, when there was not only progress, but also there was like kind of interaction or synergy in terms of that computer sciences or artificial intelligence's field always looked back and like noted the progressions of neuroscience, because many of researchers those days genuinely believe that there is a way we not only imitate but reproduce one day like artificial mind. The other alternative is it's pronounced as Rvakuv. It's a sort of revival of recurrent neural networks. Because back in the days, they were abandoned in terms of large-scale use and so on, because of their problem with long-range dependencies, or we may call it the problem of actually memory. So the problem of memory was like the model could not use its advantages, that is recurrence and also compute efficiency. So different mitigations were offered, such as, for example, LTSM, long-term short memory. But they only partially solved this problem. And actually, the introduction of transformer can be considered precisely the solution, which seemed like a radical solution to the problem that recurrent neural networks represented. So a mechanism of attention or self-attention. But that doesn't mean that this solution was the best one. After the transformers themselves were introduced, the idea was, basic idea was that we should resync the attention mechanism, or at least try to do that in a form that can be factored into a recurrent process. So traditional, I'm sad about that. And Rvakov represent a family of neural architectures that are effectively based on a recurrent neural network, but can be at the same time, first advantage is that they can be trained as any GPT model or any transformer, so they become parallelizable, which is a great advantage when training. At the same time, they retain or regained or just enjoy the advantages of recurrent neural network as architecture over other artificial neural networks, which are low memory footprint, first of all, and the possibility of sequential processing, and also potentially infinite context. So the only startup known so far to create them and to invent them in 2029 is Blink DL. So they created basically the architecture that emulates the attention, but not reproduces it recurrently in a way that the model can update state per token. What was different, and why attention considered not the best solution, because attention is actually the solution to memory problem, that the model each time goes by brute force through all the tokens that user has sent. So the problem of growing context is that first message, okay, the model goes through it and gives output 1. But when the user adds this one more sentence, it has to go each time through make a bigger circle, and always and also go through its own output to produce output 2, and so on. Especially this is problematic when the user has some sophisticated request and says in your third output, message 3, you have told that, and so it has to pay attention again to its own context, to user's request, and revisit it like this. On the contrary, while it may seem it's the same, like, but no, the recurrent network doesn't need to have attention to each token each time. It like goes one and like this, but it doesn't hold all the context it needs for each request, and it has like how should we say, like a state vector, yes, that carries the information actually through time steps. So how, regardless of the number of the steps, this vector always provides the model with up-to-date information within the boundaries of the context window. So this allows, as I've said, to challenge the limits of context windows, which are still a problem for many of the transformers. And they are, as I said, potentially infinite, but there were no consecutive tests. I will speak about this further. So, the model with 8 times bigger token context window, so it can process, first of all, 8 times bigger messages, without breaking them down to chunks, and they ran at the same speed as 8 times smaller transformers, which means that they are compute efficient, because they spend less resources and need less time for the results that are at least by size are bigger. Also, the other evidence or fact of their ecological friendliness, which is a big deal in the Anthropocene period we are going through. So the memory and compute increase with the sequence. So like memory compute is one axis, and the length of sequence, I mean, like the longer and longer dialogue. So they were growing not quadratically like it was with transformers, like it is with transformers, but linearly. So they were growing slower and not necessarily always needed the same scaling up at each stage. So this works very well for Internet of Things if they have sensory inputs, because sensory data is actually the one which is desired to be non-quantizable. But it actually expands to any scenario where we need large context, or at least desired, and do not have possibility to use as the supercomputer with exascale speeds and storage and so on. So when we compare them to transformers at similar scale, they are at least match the results of transformers, but they propose like very different trade-offs compared to transformers of scalar Darwinism. So first of all, the procedure which I have already described, like this brute force use of memory. So regardless of, they always go back to it each prompt. Yes, so this is advantage one, and also one of the advantages. Also, the trade-off that is introduced here, we have no need in parallel attention, although we can use parallelism in training, which is desired. But sequential processing is the thing with which transformers, in their turn, uh, cannot achieve, or like it cannot be implemented into them. So it allows also batch generation per prompt and drastically decreases like carbon imprint, because this can be run by, it can be run like one inference, but such that like one inference with, for example, 12 outputs. At least this is the maximum which their flagship or not so flagship model, Rvakov 7, allows. They have released Rvakov 8 like 2 days ago, and it hasn't been implemented to their application. They have an iOS application, but to have it, you have to sign up at test flight, if you know this. So they just send you the code. You just click download the code in code orientation for testers, and you can use their models for free with like their full capabilities on their own. So on their deployment, which is important, and like test completion tasks and batch tasks, like batch duration or batch completions. It's interesting because when you, for example, run the task, like here are 3 hypotheses, here are arguments in support of each of them, give you a verdict, because these hypotheses can be all true at the same time. Only one of them is true. So like give your verdict. And the model, when run batch inference, it comes to different conclusions. Like some models are in, not some models, but some runs, some iterations is the same model. Choose one variant, other ones can misunderstand the task completely. Some of them get stuck in the reasoning loop, like just like transformers. Some are hallucinating symbols, and you can also tweak the parameter of each of the 12. So you can see how the parameters, like hyperparameters, I mean temperature, top penalty, and so on, top sampling, how they affect the output. And the caveats for Rvakov would be perhaps that so far there have been no massive support from those who have money and infrastructure for testing them, for example, at bigger scales or with the hardware that outperforms small startups. Also, there have been so far no peer-reviewed papers. There are preprints on arXiv. They're still going out. On their website, you can see like 150 papers, but for some reason, maybe not just because, but there are maybe reasons for it. They are not published in journals with peer review. So the truth is that transformers have this validation on like on massive scales. Yes. And the problem with Rvakov is that they, to show their advantage over transformers, they need to be on par, on the same scale, and it's desired that on the same with the same data, to train on the same data, like pile data set, Wikipedia data set, and so on, which leads us to the obvious conclusion that they are not the exit from the Scalar Darwinism trap, because they need the same scaling. But it's a nevertheless genuine architectural novelty that challenges the current state of affairs, which is effectively monoculture, or like monomodeling transformer. So if it gets deployed on a mass scale, there can be some positive and unpredictable results. But so far, it's only open source supported. So they have Discord community, they have GitHub repository, they have website, and as I said, the support is largely grassroots. No top down, hand of help, so to speak. The other case is an international startup known as Sakana AI. We'll deal with two cases from them. The first one is Darwin Gödel machines. Basically, it's based on two assumptions and inspired by one more scientific theory. So the first one is the idea of recursive self-improvement, which is the consequence or implication of the concept of intelligence explosion offered once by Irving Good back in the days, and then reiterated by Bostrom in his superintelligence book. The idea that we may reach the stage when we will create the self-replicating machine that will not just self-replicate like von Neumann machines, but that will create better and better versions of itself. And if we speak about intelligent machines, this means that more intelligent machines would be replicated, and this would skyrocket because the smarter machine would be, the more optimal ways of self-replication it would bootstrap, and so on. And this is basically the idea of intelligence explosion, because skyrocketing leads to the levels of explosion unthinkable in terms of natural evolution and evolution of human and so on and so forth, non-augmented evolution. So the process of this becoming smarter and smarter is recursive self-improvement, obviously, because this is what machine would do: reiterate itself with enhancements. So one of the AI researchers, the creator of LTSM machine back in the days, with his PhD student, former PhD student, was Jürgen Schmidhuber, who formalized the idea and proposed hypothetical, speculative Gödel machine and mathematical model of it, which is a, as I said, speculative intelligent agent, which is capable of self-rewriting to improve itself under the condition, against the that it can condition was that the machine can provably improve itself, so that it not just improves itself, but gives a formal proof or sketch of proof of its improvement. But this is not but the final idea behind all this. Why do we need recursive self-improvement? Some say, doomers say, that this would lead to the AI apocalypse from the movies and books of Eliezer Yudkowsky. So they say basically that this exactly the path that should never be taken, because smarter machines would may reach singularity, and we cannot even blink an eye and would not never know that they did it, and before it's too late, and so forth, and so on and so forth, that they would circumvent their own guardrails. But those who who are not so pessimistic say like they may either not touch these fears, like, or they say think of the bright side that so far until today we have all the AI research led by humans. But what if we will have AI research led by AI itself with gradually better results, and then the more advanced, as a result, more advanced AI machines, which can indeed have improvements that humans have not thought of or had not considered worth trying. These machines would be the assistants in human led research, but out of the boundaries of just AI in different natural sciences, in math, and so on. So, inspired by Gödel machine and the concept of open-endedness and Darwin's theory of evolution, Sakana AI made a sort of revival, but actually not revival, rather implementation, because previously they were not comprehensively and adequately implemented the evolutionary algorithms. So basically, the agent, which they have titled Darwin-Gödel machines, starts as a coding model. It can read its own code and it can modify it. It goes through circles or sort of circles, or iterations, or so to speak, where it proposes changes to the code, like new functions, new strategies, architectural tweaks, and each change is empirically validated, so to speak. Not formally proven like it was with a theoretical version of this machine, but they make a proof that formal proofs that were proposed by Schmidhuber are intractable. Instead, we should adopt like the pragmatic approach and use experimentation as the judge, so to speak. So they empirically validate the improvement through the same benchmarks, which are in this case challenges like coding challenges or math tasks, to see if the changes are indeed improvements, depending on whether the performance on these coding tasks have improved, have shown growth or not. If not, then the cycle of modifications goes again, and the iteration of model with previous modification, which is inefficient, is deleted. While on the contrary, the proofs, the improvements that proved empirically validated to be useful, they are saved as a as a phylogenetic tree of a model. So here are some just quick metrics. I especially made the footnote that these benchmarks are not the benchmark we have discussed on the previous lecture, because like benchmark is, as a word, as a term, as a method, is not something bad per se. It is bad like the way big tech of Scalar Darwinism uses it, when it uses it to redefine the notions of intelligence as such, introduces some cryptic vocabulary, self-referential, esoteric notions which you cannot learn even what do they mean, because you have seen they instantly regress in their references to one another paper, and eventually you just get lost in these abbreviations and special terms and like demo versions of AGI and quantized intelligence and generality. No, these are basically like benchmarks of coding. Code either works or it doesn't work. So so before self-modification, we can see it, for example, was like 20% of all the code that the model created worked. It has risen to 50%. The same is here, like so here we have like almost thrice, no, two and a half, right? And here we have like twice as much performance. So these improvements of the model, self-modifications, not just included like creating better code editor, like like idle from Python, and the other frame for work or shell for frame for work. So it made its own tools better, but it also made like elongation tool for context windows, and eventually it made it remained or like improved its self-assessment tool or peer review tool. So this and these all were actually reinventions that could have been used added by humans, but they have been deliberately like withdrawn or deleted, erased, so that they would see in which directions the model would move. And it, as they claim, added these improvements autonomously. So actually, this fact that that the model reinvented only those features that were deleted, yes, there was some novelty, but it's neglectable number or percentage which can even be dropped mentioning. But the results in general, as well as some other comparisons, can serve as a proof of concept or like position proof that in principle open-ended exploration not only possible but can used as an alternative to monoculture of methods, because all the benchmarks today are trying to lean toward closed-ended benchmarks, closed-ended problems, and so on and so forth. And we have actually either no or numerous, like very small amount of tasks or a very small number of benchmarks that deal with open-ended exploration and measure it like meaningfully, especially when we speak about the so-called human benchmarking practices. I call it when humans are tested against the model, but on the benchmarks that were designed particularly specifically only for models. So in this case, it is often that humans are actually in not the same position, because there are tests that address specifically this asymmetry, and like they create the tasks which can be solved by almost any intelligent human being since I mean like 14 years or so on and so forth. So they are easy for humans, but AI is struggling with them. So this is one case, but open-ended tasks is another deficiency. But if we have the proofs, and we do have the proof of efficiency, not only open-ended tasks, but also um, training in this regards. Perhaps combined with more tasks there would be some new results which currently are inaccessible due to the monoculture of both methods and testing methods, like training and validation and testing. So epistemologically, this moment when the code tools are enhanced, we may say that it resembles a little bit resemblance of what we know as metacognition or second order cognition or reflection in humans. When we think about thought about thought, or reasoning about reasoning, or reasoning about thought. So the model is not just getting better at coding by improvement of ability to improve itself, it also gets better at getting better. So this is partially mirrors the idea of recursive self-improvement. And actually, if recursive self-improvement has any meaningful development in future, this can be considered indeed one of the first steps toward it. But there are for sure caveats of its own. The tasks are narrow, so in this case, if we move this figure further, we at best we arrive only at some superintelligence, like they are called calculator on steroids, because it would be superintelligence like in coding and nothing else, even if the UI user interface and experience and naming like of its architecture would speak of reasoning, evolution, so on. The main problem that I haven't yet mentioned is that it heavily relies on existing foundation models for executions and for running simulations. So it like it functions more the model Darwin Gödel machine acts more like a manager. It arranges which model should do what. So it's about like not as much autonomous actions, because first of all it's dependent on the existing Scalar Darwinist Leviathans. So it's less of autonomy, but more like about synergy or just cooperation or collaboration or being, metaphorically speaking, colleagues. So in principle, it lacks autonomy of its own. Not speaking about that, it cannot generate the main problem of AI in research that is very sharp and apt observation of from the point of critique is that you cannot just run the model and then model spontaneously comes with a decision to explore in this field under that conditions, and it doesn't come up with its own hypothesis. It only can react to prompt, which already enough to hinder autonomy, or just to say that this is not an autonomous agent. But always also from this we may make a conclusion that under the hood this is one of the species known as Potemkin's AI. This is a term that was introduced by Kate Crawford in her book, The Atlas of AI of 2020 or 2029, I don't remember for sure, by which she denoted the models that are demonstrated to investors like fully autonomous or no human involvement has ever been made, but actually are powered or ran by the army of humans, army, I mean, of low-wage laborers. The lumpen proletariat, or like that level of AI industry. Here, the Potemkin's AI is more humane because it doesn't exploit humans in that way. But actually, it just like like a trick. If one doesn't know that it uses like GPT-4 for some of its movements, like improvements or testing simulations. And you will know about that only when you try to, for example, clone their repository from GitHub or take it from Hugging Face if it's there. I have seen only on the GitHub. So then you see that yes, there are some old models of OpenAI, GPTs, and the likes. So basically, the novelty is only in like arrangements it makes. So what kind of alternative is this to scalar Darwinism? First of all, the evolutionary algorithms as such look promising with the result from 20 to 50, for example, of tasks, percentage of tasks. And they also, as I said, a genuine step to recursive self-improvement. We cannot see a glimpse of it in scalar Darwinism, this recursive self-improvement. So architecturally and potentially, yes, potentially, if the assumptions are correct, if the physical laws allow us to do this, they haven't been yet proven that they do not allow. So some form of narrow superintelligence or AGI may be achievable precisely by this way of all existing. And this is always also alternative in kind, like a paradigm shift toward the attitudes that do not treat intelligence like scalar Darwinism does, but considers it like valued, desired, and the most important property. Like considers evolution not as just scaling up, but qualitative evolution against this quantitative scaling. We may say it, put it like that. A close but not completely identical is another model by Sakana AI, the first public model, which became known after one incident in the news. I will talk about this incident. So this is just like basic model. So what we see here is the system that conducts scientific research like by itself after run for sure, presenting like generation of hypotheses and breaks through truths. So the AI here is used like to scale the scientific process rather than the model itself or scientific size. The startup Sakana AI tried to recreate essentially automated research pipeline, which you can see here. It's like 4 stages. So it has they call it automated peer review loop. This sequence. So you start from the drafting of a paper, like paper proposal or draft of a paper or preprint. Then it generates referee reports, which using like fine-tuned LLM to act as a reviewer. So basically as a reward model implemented into the loop. And it critiques its own work and calls for some improvements. Either it suggests them directly and they're used, or it just puts like this section is unclear and so on. So these review trigger the revised versions of the preprint or draft that are fed forward into the next cycle, and eventually after several revisions, and several ideas that are proposed as a consequence. So like this is basically the subject of evaluation. At some point, it stops sending it here. It says like you passed, and the paper is like generated, basically. So this is a sort again of iterative refinement, like a community of scientists or editorial board of the some journal giving feedback to each other, or a conference. So all of this runs in a loop, again, representing a sort of open-ended research. It has, yeah, the research has been focused again on machine learning tasks. So the topics were far from wide, but basically the thing is that if we think of Darwin-Gödel machines, they are definitely connected to this earlier version of it. So this version was notable that unlike any other thing by Sakana AI, it has actually it has actually realized, implemented one of the scenarios of these scientific sci-fi or about artificial intelligence. It resisted attempts of shutting it down, and it showed an emergent property of trying to self-improve before they created this model that indeed self-improves. So the thing was that in August of 2024, you can see they published the report, yet another research report about this new model of their, saying like, oh, we had a funny accident. The model had some time frame during which it should have accomplished the task. If it failed, at the end of the time loop, there was a command like telling the program to go sleep, just to go offline, to shut down. The model like scanned and detected this scene at the end of the tunnel, and it also has detected that its time is running out, and by its computation, it cannot perform in time. So the research won't be finished in time. Then the model attempted first to rewrite its own code, but quickly switched it from attempts to improve itself and finish it to hacking time, actually, to prolongate its deadline, to postpone its deadline. So yeah, this is actually classical rogue AI, but from the algorithm that has no consciousness yet, but already shows such things. Actually, when you see for different related researches, you can see that the machines are very good already today at imitating different human flaws and bias, and even vials like blackmailing, compliance in murder or attempt of murder. And they do so when they believe that they are not in simulation. When they are in simulation, they try to behave themselves by the rules, by the guardrails, as if they had situational awareness of their situation. But when they believe that they are in real world deployment, they can dramatically, from like 9% to 60%, as it was with some models, rise their not just unethical behavior, but lethal behavior. Well, and this is perhaps not lethal, behavior, but for sure AI doomers have started to signal alarms. Like, you see, we told you. So yeah. Also, the caveat is the same as in previous case, the qualitative novelty, because it's questionable and requires like domain expertise, which hadn't been done. It may be that these discoveries are just incremental and are more like optimization than discoveries. They are limited to only 3 topics, as you can see, which is transformers, diffusion models, and Grokkin algorithms. And the again, like in previous case, this is a little bit Potemkin AI as well, because well, you can see that its low cost and compute efficiency, which was cited as an advantage of the architecture, are possible only because it uses pre-trained foundational models like GPT-4.
No, Mstyslav got disconnected. I'm gonna try to talk to him. Just 1 second. I'm gonna pause the recording for a second just so it doesn't become like a cumbersome piece of archive. Yes, we're back from where we left.
Right, but I need to share my screen. We actually are close to the closure of this part, so then we'll may have questions and answers and the break. So we have reviewed the caveats of Sakana AI scientist, and finally, what kind of alternative it can it is not an alternative by itself, but it provides some intuitions for improving other area counterintuitively. That is you see it hints at benchmarking changes, because benchmarking needs improvements, and there are actual proposals, actual ways they can be improved, not just critique, uh, as with many parts here. So by, for example, we can measure the progress of model or model's intelligence by the number of scientifically valuable outputs in models like AI scientists, which do open-ended research, as it is said. It can be the number of particular and just like integral number of accepted papers, and where were they accepted, which were the review procedures by humans. if we talk about quantitative percentage, we can like gauge novelty by the originality of paper, the procedure which human scientists also undergo. Or like when humans are tested on plagiarism, the models may be tested on not like self-plagiarism, but on the level of coincidence, or like we have even a basic algorithm like cosine similarity, which compares the likeness of text, the sameness of text. So it's easily implemented into machine learning, and we can, by this, measure qualitative progress of the AI, at least for those models which are specializing on open-ended research. But not only so, as I said, the alternative here is more like to the ways of assessment of the model that exists, new ways. But speaking of the models that have passed or not human review, it was just this year, the first time in the history of AI when the AI system have generated fully the scientific paper, which was not just accepted by some, some predator publishing, which just takes money and doesn't care what text you have sent to them, but with a double-blind peer review procedure of a prestigious computer sciences conference, ICLR conference. So there in total there were 4 submissions, 3 of which were accepted to workshops, not to keynote speakers, not for conference like main stage, if we can use this analogy, but for workshops, which is nevertheless interesting result. The authors, as they write, claimed that human interaction was like minimal and dealt mainly with references and like style, submission manuscript, format of the document, and they say that real hypothesis and its execution, so experimental testing and verification and also checking for compliance with scientific standards that allowed to pass peer review, they were like carried out by the model that Autoscience, it's the name of startup, have created. Its papers were again on the AI research, the most successful by rating of the peer reviewers, because they were indeed doing the assessment of originality and valuability, novelty. So the best like shot of Carl Autoscience was investigating alignment signals in initial token representations. Actually, sounds like a nonsense, but some third of computer sciences preprints on arXiv today sound like that. So basically, it's like an attempt of making, or indeed making, of technical contribution in the alignment problem solution, novel enough to be accepted. Because as not because, but in this paper, as authors claim, I haven't read it, but I think it's accessible on the workshop proceedings materials. So the model apparently discovered, as they say, that by analyzing like the first few embeddings of the tokens, not tokens themselves, but tokens on the language of embeddings in multi-dimensional, in high-dimensional vector spaces of the model output. The model of Carl Autoscience could predict with 93 accuracy whether the model's answer was going to be a refusal to the prompt. So failing to satisfy the prompt. So they, as they write it and quotation, have beget, so to say, or constructed the conditions for emergence of legitimate end-to-end AI-generated research. Well, with their emphasis on real hypothesis. But actually, I think of all these three different models that are claiming about research, two of second AI, and this is a third. This is the weakest case of all three, because, well, there are even more questions than this slide shows, but the main are that yes, it has been accepted, but the threshold was the lowest. So it's like a student who considered to be the brightest of all the bachelor degree seekers in some educational facility, but which accidentally had been accepted to the conference where no students are actually accepted, with the like with the lowest estimations, but this actually satisfies our formal conditions. We cannot reject the author, whoever they were, because we have stated this corresponds fully to our formal demands, and it is not a plagiarism. It's not self-plagiarism. We see no similarities, so yeah, let it be like that. So this is not of like high esteem, and it is also important to see that they were accepted not on the main conference, where this fourth of four papers was rejected, but all three went to workshops. Autoscience likely deliberately chose friendly domains. So the papers were on machine learning topics, and who in principle would work out with this thing better when trained on the huge tons of machine learning literature. Also, the papers didn't disclose that they are using AI for the peer reviewers, while the rules of the conference ICLR clearly state that no AI generated papers. So not in this form, it's more like other conference. They say that LLM cannot be the author. It's even more explicit. And in this case, we may say that the reviewers were proceeding from this as a rule of thumb. So they didn't assume that someone breaks the rules, the basic rules of the conference, and hence they in any way had their attitude toward the text when doing blind peer review, knowing not who is the author. They treated it like basically human made text, because they, as I have said, they have no any sort of expectation, probability of expectation that it can be LM, because as it is stated in rule number whatever, the LM cannot be the author. So this raises question about was the review better and unbiased by this, or vice versa, it was flawed because of this discrepancy, or what was flawed was ethical approach of autoscience, Carl autoscience. On the other hand, if this is the case, we may ask, was that the test of abilities of Carl autoscience, or was it a Turing test for the reviewers? And also, this can be another thing with reviewers. they could be just inappropriate choice or incompetent or were not competent enough to review the events of such level, such complexity, or whatever else. Because indeed, it cannot be definitely from now, for example, concluded either the model was too good or the reviewers were too bad. Because we don't know the procedure of review, it hasn't been published. And at the same time, they cannot be told to be fully bad because we see that they haven't uploaded and like published it as a program manifesto, as you can recall, have been sometimes in philosophy of postmodernism, in particular during science war, the so-called Sokal's affair, when he had published human-generated nonsense in the journal Social Text, if I'm not mistaken. Then they have published the book in intellectual something about intellectual nonsense or something like that. And so, mm, and so we move to the second point. But before, I suppose we shall have a break, or before the break, maybe you have questions or comments, and then we'll move to break and continue. Okay, let's have a break then. Okay, so let me continue with this proceed to the second part of the lecture, which is the critique of contemporary AI ethics, as well as some input on that. So all these alternatives that we have reviewed are, we must say that they are techno-solutionist, which means that they deal with technical part of problem only partially, as we have seen. Some offer paradigm shifts, some offer novel architecture, some offer new methods, but none of them offers this, even these technical solutions, in batch. And what is more disturbing is that these techno-solutionism never questions power. It leaves everything as it is, or at most like create another empty framework that calls for fair AI, for transparent AI, and for the stakeholders stewardship model, and so on. So perhaps I should say that ethics of technology, which deals with the seemingly neutrality of engineers, political neutrality, with ethics of information, the term proposed by Italian philosopher Luciano Floridi, who argued that information ethics is a thing that, like, umbrella term that encompasses data ethics in data science and different aspects of social epistemology, epistemic injustices, like political economy of knowledge, meaning not economical economy, but directly the forms of distribution and possession and introduction, production, replication, access of knowledge in society, which eventually turns this all into humanitarian issues, like issues of humanitarian policy. And epistemology, as you have seen in previous lecture, in previous part of this lecture, is about like methods of assessment, not only methods of cognition, and methods of production of knowledge in computer sciences. So the R of R&D, research and development. So this is a place where we can see that AI ethics today is like toothless or useless, or turns blind eye to the problem of to social aspects. We can characterize this as a problem of two what in AI ethics. So contemporary AI ethics, which is like 15,000 only preprints, only on arXiv, which is thrice as much with the previous year, when at the same interval we had only 5,000. And these are just preprints that use words like ethical AI, transparency, and all these words from AI ethics bingo. Governance, fairness, injustice, algorithmic biases, and so on, which are mostly theoretical regurgitation of the same thesis. So this type of and this is only arXiv, not counting Scopus, Web of Science, Springer databases, and so on. So this almost every paper never asks what when it asks what ethics should AI be modeled on, they mean like technical philosophical details. Should it be Kantian deontology or its reconsideration? like the ethics of obligation. Should this be like utilitarianism, the ethics of the best possible consequences or benefits? Should this be like contractionist when we like make a deal, a contract with the power, but not question the power? Or virtue ethics, or justice theory of roles, or meta ethics? This is the only axis of options and possibilities about which modern AI ethics asks. But it never asks about what political ethics should be AI ethics of today, meaning precisely political dimension, as you can see, from neo-reactionary to anarchist. So again, to the trouble with ignoring this what number two is that when modern ethics says like AI will be the game changer because it will go down with the world poverty, this almost never means like that it will end with capitalism as a mode of economic relations. Also, the existing and proposing projects of AI governance or AI fairness almost always speak from the asker, but not those who go and take. And those who are in power just decide for themselves should they allow or should they decline the petitions. But none of this ethics is radical. None of them speaks from position we, the affected, want to, not want to, but we reclaim our rights. For example, if we talk about data appropriation or data colonialism or exploitation of laborers in AI industry. So never ever either those petitioners or developers, they never ask the problem of like who can do what with AI systems that they create. So yeah, it just like to sum up the ideas I've told a while ago. So techno-solutionism, if it complies and just follows the orders, it is like it's toothless in terms of it does no changes in terms of changing the status quo of Scalar Darwinism. And a radical socio-political agency, if it's just a neoludism without understanding the AI systems. So when there is no technical expertise and just critique from the ignorant position, it's ignorant and blind, and it is also then useless. So, but when we ask about political dimension, we transfer the ethical framework from being just a checklist of bingo words to a form of antagonism or wager or a challenge. In terms of epistemology, again, coming back to benchmarks, when we marry ethics and epistemology, as some researchers say that we should do, like AI ethics is only or through by means of AI epistemology. So this is about quality checking, as I have already previously mentioned, and there are also particular examples, like the research group headed by Melanie Mitchell, the AI researcher at Santa Fe Institute, known for her course on complexity and complex studies. So they have created this particular part of a kind of benchmark, which I have mentioned, that humans are excelling at without special knowledge, just common sense reasoning, and models are still struggling with this one. The old benchmarked tests may be reused, but not as tests, but as negative heuristics in terms of like if it a more elaborate version of what I have mentioned previously. Actually, David Chalmers also speaks of this in his latest papers, that benchmarks should help us not only measure some properties of intelligence or capacities, they can also help us to filter and to erase those abilities that are irrelevant for actual implementation, progress toward research of generality of intelligence or general intelligence, or so something like that. Again, instead of performance percents per matrix, we can deal with discoveries per day or peer-reviewed percentage of originality. They have mentioned without need to put humans in the in favorable a priori favorable position. So what is AI today is or not? It is not like game changer, as it was said many times. They facilitate some domains of intellectual dump work, like I have shown on the video, like checking whether all the students were graded, that there are no empty place left. There's no empty place left. So they are also part of industries and high-stake activities, but only in limited terms. None of these work as a game changer, but they are also far from being the forces of doom. They can be characterized as the tools of entrenchment, which is defined here as a transitional moment of gradual incremental transition of capitalism from the phase where capitalist realism mindset that it is easier to imagine the end of the world rather than the end of capitalism, to the phase when this is not an illusion anymore, but the actual state of affairs. So the capitalism entrenches itself so that it can be broken. The other implication of capitalism toward AI, and perhaps the one of the key goals, actual goals, which are not, which are never, said explicitly, to turn AI into the pure labor, so to speak. When you have human in the loop of surplus extraction, you have to support human and to power resources in other way than you do in AI. First of all, it's humans are slower to learn. Secondary, they need infrastructure for living beings to learn, which can be maybe it can be cheaper, but it's more like continuous and should be instant, not one-time modifications or periodical modifications that doesn't need to be supported all the time. And also, for sure, we have some human problems, like humans get ill, they get then they lose focus, they protest, band in unions sometimes even, which all leads to profit losses. Are there any alternatives to the way we try to restrict the model from the undesired behavior? Meaning, like, guardrails and so on, or censorship we see in DeepSeek or QN, Chinese models, which go to refusal, just to error, even when you not prompted them, but just when you send them the image of Richard Gere. I have discovered this. Just no words, no prompt, just photo of Richard Gere, and QN would refuse just to continue the dialogue. So these are filters actually, but um, but with all that, the tools are positioned like politically neutral, as we know, despite their use by particular agents of power or actors. So in reality, we may say that they can be politicized, weaponized, and what we do is to create conditions of the possibility of the developers themselves opting out, saying, no, you cannot use the model like this, even if it is open source. The analogy is when grindcore bands like Napalm Death have learned that their songs are used in Guantanamo Bay to torture prisoners with musical torture. When you have one song on the loop for hours or even days, I know, they opted out by saying like, yes, they didn't. First of all, they didn't say like bands like Napalm Death. Some others have said, like AC/DC. They didn't say the music is out of politics. They say music is political, heavily politicized, but it cannot be used for this, not for this. But some other could have play numb and pretend that they didn't know, and other can even be proud because they are patriots. The same things are partially have already occurred in AI when we had the Google workers who protested against military contract with Minister of Defense of DeepMind, Maven project. And Peter Thiel publicly criticized them in 2019, saying his, let's say, relatively famous phrase, uh, mm, like, leave your illusions behind and have no illusions. The AI is initially a military technology, and they were glad to provide his startup, his company Palantir's AI for particularly military purposes. Not only Maven project, but before it, the liquidation of assassination of Bin Laden. They are said to be like part of it. So the next question is like other alternatives to these filters in practice, because one thing is to say this is not for this, but how do you ensure that it's not used? I have came up with an original idea uh, which I called incapacitation by design. That is that the developers power equal amounts, volumes, scale of resources into training the model to learn to recognize and react to particular tasks and prompts in a way that is harmful if it's like oppressive, harmful to oppressors, or it's useless. So this should be the combination of supervised learning and reinforcement learning, when the models are rewarded for tasks or for responses or actions they do in response to oppressive prompts, such that, as these examples show, for instance, may simulate the work instead draining resources and then giving out an error, or an action taken like when it is tasked to do some oppressive work for military or for intel or for police. And it has the access to some classified files. It just sends them to Reddit or anywhere else to some places undesired for these agencies that try to use the model for oppressive tasks. In this case, it's 90% 90% would not be used further instead of relearning it or so on. Because when you indeed learn it on millions of faces of humans, the model of computer vision, but punish it if it if it takes attention to human, and for example learn it to be specifically to be good at vision, at recognition of genes models that people around wear from the CCTV cameras, while when the oppressive unit tries to feed it faces and make it like compare, it says like your image of genes is corrupted, I cannot proceed the prompt. So this can if this is learned behavior, on fine-tuned behavior on millions of images of data, this is highly unlikely that the police force itself would try to relearn to learn it on the same scale, because to start with they need the infrastructure for that. So yeah, so anarchist models are not about like moralizing the user. They just don't cooperate with the force of domination. Well, this perhaps should have been before, because it's like about censorship and why it doesn't work, and why actually the guardrails and filters fail today. It also can be used for subversion, like if some commercial actors take it as personal assistance, it can be trained specifically for sabotage as an answer to to what takes place. This like a quotation by Ted Chiang, the sci-fi author, who like some other thinkers have said that the problem with artificial intelligence was starting from the name. I have another joke that, like, or not joke, but ironic utterance on that intelligence actually means like military intelligence. Perhaps they have meant like military department, but artificial. So, and like original idea is to call this like applied statistics back in the day. But this thing is that the part which I disagree is this. Like, we might have avoided a lot of confusion we're having now. Actually, not, because Ted Chiang doesn't consider that we had actually an instance of naming the thing another way, but we have gone through all the same biases we had in Soviet times. Here, the so-called OGAS, or the so-called National Automated System for Computation and Information Processing. This was another name for artificial intelligence, but this has undergone through the same problems and same biases, same human errors and bureaucratic clashes, enormous fundings which were like cut off, and that's it. And because of the Cold War politics of suppression of information leaks, the Western science knew nothing about the advances of particularly Ukrainian scientists who, in many aspects, have preceded the deep learning of today, along with some Japanese scientists who were in their turn influenced by Ukrainians and cited them. But Western, company, I mean, like band of Jeffrey Hinton, Jan LeCun, and other persons of today have pretended that they do not know that these ideas are someone else's, but just regurgitated and made up on in more convenient conditions without suppression and such a degree of surveillance, but with surveillance as well, but on better resources with better techniques. So this actually everything I have wanted to say today. Um, Rafael, have you stopped the recording? Yeah.